Hello everyone, welcome to this video. In this video, we shall be looking at question number 16 from exercise 9.3. So the question here says we need to find a GP for which the sum of the first two terms is given to be minus 4 and the fifth term is 4 times the third term. So S2 is given to be minus 4 and the fifth term, which is A5, is 4 times of the third term, which is A3. Right, we already know about the formulas for the nth term and the sum up to first n terms of the given GP. So the nth term is given by this formula an, which is a r raised to power n minus 1, with a where a is the first term, r is the common ratio, right? And Fn, the sum up to first n terms, is given to be a 1 minus r raised to power n divided by 1 minus r. Why I have chosen this particular formula? It is because I am assuming that the sum here is negative. So that means the common ratio is less than 1. This thing, I am guessing this thing from here, correct? So now we know these two formulas. We are given S2 is equal to minus 4. So therefore we can apply the formula of S2 by putting n is equal to 2 into this formula. So we have a into 1 minus r raised to power 2 divided by 1 minus r. Correct? Now you know the formula a square minus b square. It is a minus b, a plus b. So we can apply this formula here. We can write 1 as 1 square. So it would become 1 minus r, 1 plus r. This 1 minus r and 1 minus r would cancel with each other. So we are left with this thing. Let's mark this as equation number 1. Another thing that is given to us is a5 is equal to 4 times a3. So that means a5 is what? It is ar raised to power 4. That is equal to 4 times of a3, which is ar square, correct? Now this a and a cancels with each other. This 2 power cancels with 2 power here. So we are left with r square is equal to 4. This gives the value of r as plus or minus 2. Now we obtain the value of r. What we are to find? We are to find the GP. So that means in order to find the GP, we require two terms. That is the first term and the common ratio. Now the common ratio is obtained to us. Let's determine what is the first term. So when the common ratio is plus 2, in that case, what is the value of a? We can obtain the value of a by putting equation 2 in equation 1. That means the value of r in equation number 1, this one. So we have a into 1 plus 2 is equal to minus 4 here. Solving this gives us the value of a as minus 4 upon 3. So that means in this case, when r is equal to plus 2 and a is equal to minus 4 by 3, the GP would become, the first term would be a, next term would be ar, next term would be ar square, and so on. So the first term is minus 4 by 3, next term is a multiplied with r. So this multiplied with this, which is minus 8 by 3. Next term is ar square. R square is 4. 4 into minus 4 by 3 give you minus 16 by 3. So you can have all the terms in this way when r is equal to plus 2. What about when r is minus 2? When r is minus 2, we can obtain the terms again by substituting the value of r in equation number 1. So we have a into 1 minus 2 is equal to minus 4, correct? Solving this, we have the value of a as 4. When a is 4, r is minus 2. What do we have as the GP? The first term is a, second term is ar, third term is ar square, fourth term is ar cube, and so on. So the first term is the value of a, which is 4. The second term is a into r, 4 into minus 2 minus 8. Third term is a into r square is 4. 4 into 4 is 16, right? Fourth term is ar cube. So r cube would be minus 8. Minus 8 into 4 is minus 32, and so on. So this forms the GP in the case when r is equal to minus 2, and this forms the GP in the case when r is equal to plus 2. Correct? So this is about question number 16. Now let's move on to question number 17. In question 17, they are saying that if the fourth term of the GP is x, if the 10th term of the GP is y, and if the 16th term of the GP is z. We need to prove that these x, y, z, they are in GP. So in order to prove that these three are in GP, what do we require to prove? We are required to prove that the ratio of the third term to the second term is equivalent to the ratio of the second term to the first term, right? That would be the common ratio. So that means we need to prove that z upon y is equal to y upon x. So if we prove this thing, we are proving that all the three variables x, y, z, they are in GP. Now it is given to us that fourth term is x, so a4 is x, 10th term is y, so a10 is y, and the 16th term is z, so a16 is z. So we will be using the formula for nth term as an is equal to a r raised to power n minus 1, right? Substituting in this formula, substituting the value of n is equal to 4, n is equal to 10, and n is equal to 16, we have these three terms. a4 would become a r raised to power 4 minus 1. 4 minus 1 is 3, so a r cube, and it is given to be, a4 is given to be equal to x, right? So therefore we have a4 equal to x. Let's mark this as equation number 1. Next, when you substitute n is equal to 10, you have a10 as a r raised to power 10 minus 1, which is a r raised to power 9, which it is given to us as y. So we have a r raised to power 9 is equal to y. Let's mark this as equation 2. And similarly, when you substitute n is equal to 16, you will arrive at this third equation. Correct? Now look at this result. We wanted to prove this thing. So that means in order to calculate this y upon x, what we need to do, we need to subtract, we need to divide this thing by this thing. So that means we need to divide equation 2 by equation 1. Doing so, we have y upon x in the right hand side, and here we would have on the left hand side as a r raised to power 9 divided by a r cube. Correct? So this a and a cancels, we are left with r raised to power 6. The powers would subtract, so that we have r raised to power 6 is equal to y upon x. Let's mark this as equation number 4. Now another thing that we require is z upon y. You see, z upon y is obtained when you divide this z upon with this y. So that means you will divide equation 3 with equation number 2. So that on the right hand side you would have z upon y, and on the left hand side you would have a r raised to power 15 divided by a r raised to power 9. So this a and a cancels, the power subtract, so you would have r6 is equal to z upon y. So mark this as equation number 5. Now on comparing equation 4 with 5, you see it is r raised to power 6. It is also r raised to power 6. So we have y upon x is equal to z upon y. From here we see both of these quantities, they are equal to each other. Hence the terms x, y, z, they are in GP. So I hope you understood these two questions well. Well, that is it for this video. Thank you for watching.